Okay, welcome everyone. This is trustedfirmware.m Open Technical Forum. My name is Anton Komlev. I'm a technical lead of this project in ARM, and I'm hosting this project on behalf of trustedfirmware.org. So today we have only one technical topic to discuss, but we have a number of them in the mailing list, so we can touch those topics. But before that, let me share this few news. One of them is now we have one more board supported as a target for TFM. This is NXP board, recently merged to the main code. Yeah, welcome NXP. Good, congratulations. Yeah, another news is now we add one more toolchain. This is IR toolchain, compiler, and link and everything. So in addition to GNU, ARM, and CLang, now we can use IR. Yeah, congratulations, and yeah, great job. That's the major news I had so far. If you have anything else, please share. Okay, and now we can go to the topic. What we have for today is improvement of secure function calls. You may remember that was one of the hottest topics even before this Open Technical Forum, and it was touched on the first, second sessions. And there were several improvements and ideas for improvements, not the improvements, how to do it better. And today Ken wants to present his research and his finding, how he thinks it can be done. So Ken, please share.
Okay. Let me share my screen. Can you see my screen?
I do.
Yeah. Okay. So the topic here is about the handle management mechanism enhancement. It's a precondition for the fast load service API call. So the content is just 3 parts: the background, the design itself, and the discussions. So let's jump to the background. So in our previous tech forum happened at January 23rd. Some partners commented that the PSA Connect call close process would cost much for some one shared service call because they want to do very simple things in that service. So they found that they need to connect and close every time. And sorry, okay. So here is an example how we encapsulated the load service API today. So inside the implementation body, we need to do a connect to get a handle. And then we do a PSA call on that handle. After the call is done, we need a PSA close to close the handle. And then we return the status. So we look the list implementation and think about the comments. Then we start some investigation on that. So here are some assumptions before going. The first point is that avoid value significant changes in the PSAFF, because that would make the TFM a very customized implementation and not aligned with PSAFF much. And the security consideration is just follows the PSAFF, so which means that a connection-based mechanism is still necessary, so that the SPM and service could identify the clients. And the collecting process is known by the services, which means that the service just work as usual. It processes the connect message and allocate some internal data objects for that connection, and it could maintain different client status inside it. So let's go through the analysis and the possible implementation. So first the source. When do we need to call the PSA Connect? Here are two general API usages. The first one is the section-based service API, which means that this API is a typically a API set. So it has a section setup operation and various subsecond operations on that section. And then after all the job is done, we call some close API to close the section. So in this case, the API, the PSA Connect can be embedded into the session setup process, and during different functionality, we can call PSA call on that handle with different types. And after all the process is done, we close the section. During the closing procedure, we call PSA close to close the handle. So for the section-based service API, the PSA Connect is not a problem because we can call PSA Connect during the section setup. Right? And the connecting cost was diluted in their function call because there are many function call happen on that section. So for the one-shot load service API, which is sectionless, which means that it does not need to work on a section. So typically we want to reuse the connect handles so that we can call PSA call on that handle anywhere. So the right side is the typical diagram. We call the client init somewhere, and we got a handle connected to that service. And then when we need to do some APIs, we just call PSA call on that with the separate handle. Right. So the one-shot 1, 2, and X may happen different places inside one client. And finally, during the client destroy, we would call the PSA closed, close the handle. So that's the second usage for the load service APIs. So for the second API usage, a typical design can be we just store the connected handle somewhere. We can store it as a global variable. If the then if because the load service API is implemented as a library, and then it may be shared by multiple clients if there's no isolation between the clients. So sometimes we need to reserve different handles for their different clients, and even you don't want to create many handles for the clients, then you need to share that clients in an isolated system. It would involve more system level support to support that because you need to put the shared global to the process info, and the data system know that this global is shared, and mapping that global to each process's visible address range. So in that case, the global is not ideal. Save it as a global is not an ideal solution. So in that case, we can create some abstracted allocation API to let the system implement the API and do the handle memory allocation and management for you. So this would involve the abstraction layer into the library. So which means that if the root service API library, it can before this it can be a pure C source library and just rely on the PSA headers and libraries. Now it involves more. It need to rely on the abstraction layer, and the abstraction layer need to rely on the system APIs. It involves more dependencies. And if for a system without memory management API, the user need to create one for it. The third case is that you need, when you're creating the abstraction layer API, you need to tell an identifier identification to the API to let the abstract API layer know which color is allocating, which color is getting, try to gain the corresponding handles saved in that place. So this is possible, but looks not very nice, not very neat. So here comes some thoughts. So if a service handle is known already, which means that a service handle is a fixed value, for example, 2, 3 or something, then no handle storing is needed. The client just can perform a PSA call on that known handle value and get the result. To do that, we need to support that, right? We need to support because we need to support assign different client with same handle value for the same service. So we need to implement that mechanism. This mechanism is now is implemented node in the PSA-FFM. It is just a recommendation, but if we wanted to support at least a fixed service handle value, we have to implement it to make it as a mandatory design item. So if that is supported, then it looks like a neat solution because every one-shot service client, it can just do the previous call on a known handle with some types. So here's a diagram to show the handle map now and the future to be added. The dark blue side, the global handle map is now what we have. During the PSM, the connection actually is allocated from handle pool. It's just a memory address, and then we need to map it to some Unicode value, and then return to the client. That's what we are doing now because this if we use just a function to do that map, it will hide the memory information inside of the SPM and just return the Unicode value to the client. But the Unicode value is global, global Unicode, which means that for example, client 1 get 17 and get 18 two handles, and the client 2 never got a chance get 17 18 again. It needs to get the 19. With this implementation, we just share global HMapper or share a global handle mapping mechanism is okay. Maybe not a table, just a mechanism is okay. And to do the to map the same handle value to different clients, we need to put it per client handle mapping table inside the client data structure inside SPM because each client has a instance inside SPM. So SPM knows which client it is. So we can create a mapping table there and do the mapping. So in this, for example, this case, we got a client 1 handle map. For the one-shot user service, we allocate a memory address from the handle pool, and then we through this mapping table to return the handle 1 to client 1. For the client 2 is still the case, so we got a client 2 handle map. We got a different memory address inside the handle pool, and we use the client 2 mapping table to map to the handle 1 for client 2. So that's the idea, I think. So here comes the architecture level proposal on the PSA-FFM. So first, we need a new manifest item for services who want to support the default services, the default handle value. So there's a this manifest item default handle. It can be a number or a pattern. If we assign it as O2, which means that the whole building system would assign the fixed handle to list for this service. And if we assign the fixed number for it, then we will got the fixed number for the default handle value. Obviously, the building system needs to detect the collisions between them to check if they are duplicated numbers detected. So if this field is not available, just what we have now, it's a legacy RPC service. So no default handle value for this service. So yeah, we cannot perform PSA on that because we don't know the default handler number. The default handler value assigned is aligned by the framework of the implementation auto-connecting. We prefer the implementation auto-connecting, which means that because the connecting is still needed, we prefer to do it in an implied way, so that the service caller won't change. He can see the connect messages coming, and it just do the connecting operations. And for the client, it does not need to call the PSA connect explicit, and he just can perform a PSA connect. So with this proposal, the no handle storage is needed because the default handle value is known. The client PSA connector to this service is work as usual. It can connect to that and get a global Unicode handle value, and he can do PSA on that. Even he may already got a default handle value for this service, but he still can perform a PSA connector on it to get another handle. Closing a default handle causes panic because this is a hint to the developer that you are closing a default handle, and it's not allowed because some other execution place inside this client may using this handle. So if you are trying to close the default handle value, it will cause a panic. So here is the implementation part mostly. We need a system tooling to generate the default handle value, generate into a global header file or somewhere while building. If the default handle is detected, right? So for example, we got a PSA service A. So in this generated header file, we define the macro value. Define a macro for the default handle. Here we allocate 3 for it. And in the root service API implementation, there's another C file. It just perform a PSA on that call on that handle. So then we can just call root service API, root service A with a PSA call. We don't need to call the connect and close again. So that's the idea. So about the auto connecting, it's really the implementation part. Here is the example in TFM. We prefer to do it inside the SP runtime. We got a SP runtime library inside TFM, so we need to create an unified partition interest inside the library before launching the. Sorry. So if okay.
I want to ask if somebody not going to talk, so please put on mute. Thank you.
Okay. Thank you. So here is pseudocode. So before calling the real partition entry, we do some implicated operation here. We can connect to the all the default handles and ensure that ensure all the default handles this client needed is connected, so that the partition could just work on that. For the non-SQL client, it's still the same because non-SQL client still got a partition instance in the SPM side. So it will jump into this main function too before jumping to the non-SQL side. So which means that all the default handles needed by the non-SQL side is connected here. So the non-SQL side still could perform a PSA call directly on the default handles. So that's the idea. So finally is the discussions. So because someone may worry about the memory usage, it should be tiny based on the analysis. So with this proposal, we need a per client dependency storage, like I mentioned here. It should be tiny because typically we just save their dependent services who support a different handle for that client, so it won't be much. And then we got extra logic to dispatch different handle in the SPM, which means that if we see this handle value is a different handle, we would seek the real internal handle memory address from the client table. So it's code logic there. And in the auto connection inside SPM runtime, so this code, this code is shared by the client, by the partition, by the client. So it is a shared code, just the size of list function, right? So from in theory, it should be tiny increment, and the performance it's almost the same. So a table lookup is needed for sectionless services, which costs several more lines of code, so it should be fine. And because we are now pushing this proposal to PSAFF, so it will be a TFM feature initially, and we are working in a parallel to push this proposal to PSAFF. So that's it. So that's it. I tend to go through the slides very quickly. So if you got a question, so we can jump back to the one of the pages and we can discuss.
Thank you, Ken. Thank you. It's quite a big step what we expected, and I believe there will be many questions. So please. At the same time, it may take time to digest it. But yeah, somebody want to ask something, please.
Yeah, just on fly the wall here a little bit. Have we considered the other option of doing direct service mapping through a non-secure callable and forgoing the whole connect, call, and close scheme as an option for even simpler interaction with one-shot service usage?
Why did you rule this out? Good morning, this is Reinhard. Good afternoon, depends where you are. Why did you rule out this option that you have just mentioned?
Sorry, I cannot hear that question clearly.
Instead of having one single entry point for the whole PSA, I think Reinhard wanted to know why it has multiple non-secure callables not been mentioned or looked at in terms of simplifying, for instance, one-shot service calls.
Do I correctly understand that proposal is to have single entry point for all PSA services?
Yeah, I think a single entry for all PSA services is okay. There is no problem with that. But why do you need, or let me ask differently, is this for inter-process communication and for what you call today library mode, what should be in reality secure function mode? Is this the identical connect sequence, or is it different when you have a secure function mode? I mean, here you have IPC call. Is this an IPC implementation of the access to PSA services?
As I understand, Ken, the question is, will this proposal work the same way in IPC and library modes?
Now it focuses on IPC mostly. Yeah, because we don't have a connection or some mechanism in the library mode. So because my library mode is already a direct function call and it does not have a connection section something.
Yeah, no need for this.
Do you have somewhere for the V8M single core processors a list of benefits, IPC versus secure function mode on the behavior? What is the benefit of IPC And what is the benefit of secure function mode on V8M single core?
I think it's out of topic question, but yeah, Ken, if you
I think,
wish.
okay. I think Andrew may be the best person to answer this.
I think, yeah, Andrew, if you wish to talk to.
Yes, so this is a sort of like a first step in, certainly in IPC mode, this is addressing an issue where you have APIs that are stateless and or certainly don't require or expect to have some kind of stashed handle for the connection in the client API. And so it's sort of like reducing the code complexity in the client, where the idea of having a default handle to the service, an implicit connection, is helpful. We're planning to basically make further proposals on the service side to have a secure partition either implemented as today, where you have a thread running in a sort of message pump where it's basically waiting for a signal, pulling a message out and then dispatching as the developer requires. It gives more flexibility to the developer in terms of writing their partition code. But in many cases, the partitions and the services are simple enough that actually writing a set of service handlers which act as callbacks and allowing the framework to manage the, if you like, the dispatch process, and it invokes callbacks sequentially based on the incoming messages. So that's the next step of the proposal. At this stage, for this proposal is not removing the connection as seen from the service. So the service will still see a connection message per client that uses the default handle, because that allows it to maintain service-side resources that are associated with that client in a fairly simple way. So there'll be a follow-up which will propose changes to a service definition which allow the service to be written with a callback function rather than writing a main sort of an entry point with a message processing loop. And at that stage, there may be one or two further proposals which might streamline the operation a bit further. But we get to a point where we have, if all the services are written using default handles and callback functions, the actual client, the API from a client and a service perspective now looks very similar to the library model, the secure function mode. And so what we're thinking about is whether we can have the architecture essentially have what looks like a spectrum of ways of writing services and clients, such that if your system is designed to use the simplest mode only on both client and the server side, that the framework can be told to essentially use a secure function mode of framework. So essentially you replace an IPC framework with a secure function style of framework, which can only support services that have use default handles and callback services. So at the architecture level, it looks more like a spectrum of options for writing services and designing client-side code. And at the sort of, if you step back when you're building the actual system, if you implement just simple services which use default handles, you can ask the framework to actually use a completely different design, which looks like library mode today. Mm-hmm. So that's the kind of like the grand ambition is to, and in the process, we provide options in the architecture that allow IPC mode to be more efficient for both clients and services, sort of where required, without removing the the flexibility that connections and being in control of a secure partition thread provides for some system designs.
Yeah, I understand that the IPC mode has benefits for multiprocessor systems. For a single processor system, it might be challenging actually to schedule processing time. Also, given the nature of a microcontroller, where usually time-deterministic operation of the user application is an important consideration. So I think you have to balance that, and therefore keep it simple sounds more reasonable to me. Therefore, I have not fully understood your callback scheme, to be frank.
So today, if you're using library mode, as it's currently referred to in TFM, the secure function mode, when you define a service, what you're providing is a service handler which runs in the secure environment, which is a function that's called with parameters which describe the request. And then the system essentially builds you an API from the client side, where you provide the IOVEC parameters, I think today. And then the framework essentially tunnels the request from the client to the service handler.
Yeah.
The framework calls a service handler on a secure stack with the right parameters. So today, when in IPC mode, each partition creates an entry point, and the entry point is expected to enter a loop where it waits for signals. Based on the signals, it will then get a message, and then it will process the connect REST messages and primarily process the request messages. So in a partition which is only running services, that loop is going to wait for the signals, and then switch on the signal bits and essentially invoke message processing functions with the messages it's retrieved. So the second proposal is going to look at essentially moving that sort of main loop inside the framework. If a partition selects sort of secure function mode, then the message polling loop will move inside the framework, and the service writer just writes the service processing function. So for each service, you declare, I've got a handler function, and that will be invoked with either a message parameter or parameters that basically correspond to the message. It might require, we might want to evolve the API used by the services so that it aligns with IPC mode, because that means we get better code reuse from the service side between the different styles, but that will be subject to the proposal. Because the framework does the message polling, there's no requirement at that point that the service actually writes that as a message polling loop inside a thread of execution that is inside a secure partition, because the actual service can't see that. So you could design a framework that says that isn't implemented like that. You could write a framework that's implemented like the secure function mode, where a request is made, and then the implementation of the framework identifies which stack to execute the call on and executes the call. It doesn't have the need of independent scheduling, because there isn't the concept of threads running in a secure partition, because you only get individual callbacks that occur inside the secure side from the service developer's perspective. So it's never, that in the IPC mode, secure partitions, from a programming model perspective, you have a thread that you're in control of, and you make calls to the framework. And in this handler mode, or however we refer to it, when you have services running in this callback mode, you're a function that's called by the framework, and then when you return, that's the reply. So you can't park a message and process another message while you're waiting for a response from some hardware, which you can do in the IPC mode. But for simpler services, it avoids writing that main entry point loop, but it also allows, if everything looks that way, to actually replace the framework with the IPC framework with the much simpler sort of library style design. If you've got the right underlying system and all of your services are designed to be callback based. So you'll have to wait a little bit while we sort of like pull together our thoughts around what exactly that looks like. But that's kind of like to give an idea of where we were trying to go with this. And that this is solving a problem on the IPC side. Admittedly, there are some trade-offs in the design, but it's solving a problem there, but it's allowing us to reach a point where we can provide an overall architecture that actually allows an implementation to be to operate in secure function mode.
Okay, Andrew, thank you. My feeling is we need to standardize terms. Either it's library mode or secure function mode. I don't think we should use both terms in parallel. And I don't like library mode because it's actually not a library. A library in software terms is a collection of modules, as you know. But that's only a minor detail from my perspective. Thanks for the explanation, Andrew, and I will look at it and come back.
I was going to say, I think what we can do if we come up, as we sort of like bring a sort of like a, maybe I'll work with Ken and we'll try and do a sort of like a few slides on like the roadmap of what we'd like to get to, and maybe we'll then describe, well, what are we proposing to call this alternative mode, because it'll eventually, as it sort of like settles down, it will involve replacing a lot of mostly documentation text that is in TFM. But so that there's a roadmap of, okay, this is where we want to get to, and these are the steps we're going to make, and how those steps affect the different systems, and then it at least gives a view of going, okay, well, where are we in that roadmap when we say, okay, here's the next proposal. And it makes it easier to measure whether that how good that proposal achieves the sort of like the end game, the end goal.
Okay.
And yeah, this is not merely a sort of like trying to evolve TFM to the point where we have a sort of a better alignment between the different frameworks designs. The plan here is actually parallel extensions to the actual architecture specification. Eventually, we'll have a version 1.1, which has this full support for what's being described here.
Okay.
So it's not just about the TFM implementation.
Okay,
follow-up question with regards to the IPC mode and the secure function mode. I think we have coined the term. What about having both? Meaning that there are specific services that do IPC, but in the off chance you would need high responsivity and you don't want extra complexity, what about having stateless or default handle services as secure function and the rest of them an IPC? Have you considered that?
Yes, in some sense you have this sort of we haven't, I mean, hadn't really thought about the implementation, what the implementation would look like. But if the architecture does not require services and to be exclusively one or the other in an entire system. If a system design said, well, this partition is secure function mode, and all the services have default handles, and we might have and may say, look, or we go further and say there's no actual connection basis. It's just, you know, there's this idea of a default handle that's used to actually make the request go to the right service. But if you have one partition that says I'm secure function mode and another partition that says I'm IPC mode, obviously one approach is in that model everything's IPC under the hood, and the secure function mode partitions just have a framework provided message loop. But the other approach would be, okay, the actual framework implementation becomes a little more complex because it includes both the ability for partitions to have signal sets and run as a thread context, and other partitions to have dispatching done directly by the framework. Now, that improves the latency for the secure function-based partition services. There is more complexity in the framework, and the framework still has to have this concept of being able to schedule the IPC-based partitions. But it can make its own decisions about the scheduling priority, because it still looks like scheduling at some level in the framework, but of the secure function mode partitions. But they could involve, there would be more options for looking at and say is, depending on the isolation level, you can have more direct execution of the secure function mode services. So that's clearly an option. The architecture is definitely not going to want to rule those kind of designs out, so that an implementation can basically, you know, keep things simple, but then may decide, okay, we can actually optimize secure function mode services even in a sort of mixed system. So I'm keen to make sure that the architecture allows implementations to make those kind of optimizations or those kind of design choices. And that's partly why I'm happy to be working with Ken on just not merely trying to specify an architecture abstractly or trying to write down what TFM does today, but actually describe an architecture that provides a sort of a better spectrum of options for systems and for the implementation.
Sounds great.
Okay, thank you. Thank you. For me, this sounds more like a implementation decided thing. Yeah, thanks for that.
Sorry. Yeah. I have one question. You can hear me?
Yeah, please.
Yeah. So back to the proposal by Ken, I think there's so what he want to do is do the PSA connector on the SKU side and saves the handle in somewhere. Yeah.
Yes, that's it.
Yeah, but you know, there has the one parameter as the PSA version, framework version. Yeah, and there also has API PSA versions, and should be called in the non-SKU side to lets the non-SKU application to check if the current version is supported by the TFM. Yeah, so so that if we put the PSA connector on the SKU side, and how we decide is that the version is the right version, is the non-SKU side wanted. Yeah.
This is a good question. So yes, this is a good question. So actually for the client, which vision of the service it want to call actually is decided by the clients. We can do some implementation that provide that vision information somewhere inside the client, and when the because while the secure partition runtime is connecting to the service, he is referencing their client provided date. In that case, he definitely can get the expected vision and connect to that. Yeah, that is not included in this proposal, so this is a good question to mention that, but I think it should be not complicated to be handled. Yeah, that's
Yeah.
it.
Okay.
I'm going to put a comment in. Just the original design intention around version was considering services where, I mean, today most services are defined by their C interface, and clients call the C interface, and the version is not exposed to the client. And the version idea was because for some services, we thought that they might actually want to define the interaction as the IPC protocol, so the actual set of messages that get sent. And if you define it at the protocol level, you need a way of determining what version of the protocol you're using. This is still somewhat useful with the C API, but only in systems where you might build the service completely independent from the client, and the service provides a client library, and the client gets built against one version of the client library, and then you update the service, but you're still running the same client code. And then you might get a mismatch in terms of the IPC messages that get sent if internally the IPC protocol has been changed by the service writer as they've updated the service. And using an IPC version using a version number on the connection allows you to detect whether you've got a mismatch between the client library and the service itself. The idea of using default handles is especially the sort of like the simpler version where you let the framework allocate the handle for you, so you don't end up with collisions between services who want the same default handle value. Requires that you are simultaneously building the clients and the service, because, or at least the SPM is recording somewhere what the allocated handle values are, so that they don't change between different builds of the same software stack. Because if you build the same software stack twice and you have different default handles, then you have to make sure you don't have a mismatched between the non-secure and the secure sides of your system, because they'll have disagreements about what the default handles mean.
Would it in this context not better to basically have a service number and a function number and combine them? So that when you basically a service has a fixed number and then can add several functions as needed. Sorry when I use now the terminology of functions rather than services.
So well, I mean, at the moment we have the idea of this global name for a service, this service ID, which works well for connection-based services, and you specify the version at that point of connection, because we previously looked at whether we could add some kind of one-shot call on what is today the IPC mode, where you specify, instead of a handle, you specify the service ID and the version, and then the rest of the parameters. And that potentially could work, but you're then having the overheads of service lookup and version verification, and it's more parameters, and it's another API, and so it's kind of, the alignment gets more, it's a bit more challenging. And what we were looking for was, what Kenma's thought was, if we could do it in the handle space rather than the service ID space, then that works very well for simple systems where you can build a secure function mode, because in the systems where secure function mode is actually an optimization, then you're likely to be building in the secure and non-secure side firmware together, and things are simpler. You're not going to have very complex systems which need a very large number of services, and because services can have multiple message types. So I'm not thinking that the crypto service would be multiple services. It might be one service, for example, with lots of different message types to actually differentiate between the operations. There are different trade-offs, and we didn't want to end up with a static sort of function that has so many parameters that it ends up requiring a lot of in-memory transfer to get through the secure gateway. So that we'd like to streamline it, the API, to the point where you can dispatch through a secure gateway with less memory copying required, which then optimizes the call path from the client into the service. Because every non-secure memory buffer that you have to transfer requires validation of the pointers and the memory ranges. So that's part of the sort of like the idea in trying to use the handle space here, because one, it reuses the API we have in the client, and the actual values allocated to handles are entirely within the control of the implementation today. So the framework can decide what the handle values look like, whereas the service IDs are essentially defined by the architecture. So there's not a lot of freedom to sort of use significant range of those for this kind of purpose. So I mean, in terms of the version, part of the aspect of what version the client is expecting can be built into the client, or the runtime library that's linked into the client. I mean, Ken's proposal is that the actual default handles are all connected during runtime, the runtime initialization. And so the version that's expected is actually baked in here into some table that's actually inside the client. And so if the caller is expecting this version because that's what they compiled against, because that was the manifest version, the version of the manifest that was used when the client library was built, then that might be different from the actual version of the service if there is the ability to build them differently. And so the version would still be picked up here. If the connection was done inside the SPM itself, which is an alternative way of designing this, then it's likely that you wouldn't get the client wouldn't explicitly be able to express what version they're expecting. And that might still be appropriate for systems where you're always building the non-secure and the secure side together, or you're tracking the versions of the two sides in a different way within the tooling.
Andrew, excuse me, please. Just remind, we have 4 minutes left.
Sorry.
Please, yeah. Just to remind you to finish.
Yeah, I think it needs to be explored exactly what the implications of hiding the version is, which is what happens here, but also just understanding just where the version is significantly valuable today, where it's done explicitly when you call connect.
Okay.
Yeah, thank you.
Thank you. I think we have 3 minutes left. If you have small questions, so please try to ask.
Have you considered an extra function just to get the do the address lookup potentially once during startup, and then just use that, a hash or whatever as a substitute, the actual values.
Well, that suffers from the original problem, which is where do you put that's like calling connect and stashing the handle. Where do you put the handle? The problem, that's the original problem spaces. That was the assumption that it's kind of like the assumption that the original IPC design said is that the clients have somewhere to put the handle, and then they can keep that handle and keep reusing it. But somewhere to put it means global data, but global data, if the scope of global variables is exactly the same as the scope of an individual client from the way that either the non-secure side or the secure the SPM is separating clients, then it works. But if clients share global data, or global data is visible, or global data is not really possible, then you can't stash the handle in global data. And so that was where Ken said, well, the other thing is you abstract where you store the handle, but then you still need the notion of a client identity and a mechanism to look up the handle for that identity, that client ID. And that has a platform dependency, and it doesn't necessarily, and that is just moving the problem to another layer. So the proposal here is saying is, can we have a value that is a build time constant in the client that actually refers to a connection which it can use, and that the framework ensures that that build time constant refers to a different connection for each client. So essentially each client gets its own connection, but the client doesn't explicitly have to manage it and manage the value of that. You know, it's not a dynamic handle which is which depends on the SPM to basically, it returns a value that you then have to remember. You need writable data for it.
I think you misunderstood. I thought in the replacement of SID, version here into either a pre-qualified constant that you can do from client side just on startup and say that, yes, the services match all the versions that I require, and the service is indeed present. And then you can just use a hash over those two, something like this for subsequent calls.
Frank, can you ask this question in the mailing list, and we
Yes.
can continue the discussion?
Will do.
Yeah, thank you. I think we are over in the time for this meeting. I think it was very interesting and fruitful discussion. I'm pretty sure we'll get back to this in the mailing list and maybe in the next sessions. Thank you, Ken, for this presentation. Thank you, Andrew, for explanation and the whole good questions. Please continue to them in the mailing list. And I think we should close now.
Okay, let me stop the sharing.
I guess it's worth putting this proposal somewhere appropriate for either in the mailing list or somewhere on josephverma.org, so that
yeah, right. I think all presentations what we have so far, except one, but I think it will, are available in the trustedfirmware.org in a forum session, as well as whole meetings recording. So if you want to listen to it once again, so welcome to trustedfirmware.org in the forum session, so you can see presentations and recordings. Yeah, one news what I forget at the beginning. So the small profile of trusted firmware of TFM got several comments, and it was updated. So thanks for the comments. Take a look on the final version. I think it's still under review. And with this, I want to say goodbye. Have a nice day, or end of the day. And since in China is a big holiday from tomorrow, have a nice holiday, China. Goodbye.
Okay, thank you.
Yeah, bye.
Bye-bye.
Bye.
Thank you.
Thank you. Bye-bye.
Thanks, bye-bye.
Bye-bye.